Alright, so today we'll be talking about dividing polynomials. In other words, dividing an entire polynomial by a monomial or a binomial. Okay, so we got some interesting things going on here. So, first off, turn the problem into long division problem so you can properly do it. Okay, this is basically long division for algebra. Okay, so we draw out our long division, pretty simple. So our divisor goes out here, so this is 4x to the fourth. Okay, and then inside here we're going to have 12x to the eighth. Okay, now what you're going to do is you're going to actually write out all the terms in between. Okay, so plus 0x to the seventh plus 0x to the sixth plus 0x to the fifth plus 0x to the fourth plus 0x, well, not 0x to the third, that we do have that. That's minus 8x to the third. Okay, let me get rid of that plus. All right, so as we work this out, now what you're doing is you're actually practicing placeholders, because later on in Algebra 2 you'll learn another method, and as long as you learn that this is what we're multiplying into, you should be good to go. Okay. All right. So first off, what we're going to do is say, okay, how many times does 4x to the fourth go into 12x to the eighth? Okay. Well, 4 goes into 12 three times. That's pretty simple. X to the fourth goes into x to the eighth. It goes in x to the fourth times, because remember, when you multiply, you add the exponents. So I'm going to multiply these two together, and we're going to get 12x to the eighth. Okay, and what we're going to do is, just like long division, we're going to subtract the two. Okay, and we're going to get a big fat 0, which is nice, which is what we want. Okay, and then if you notice, if I bring everything else down, I'm going to have can't go into here, can't go into here, all the way down. Now here's the funky thing. Okay, I'm going to ask you 4x to the fourth. Now technically, here, I wanted to show you what that represents. Technically, since I'm not going to do anything with that, you can just go ahead and bring this down to here and just rewrite it there. But I wanted to show you just so that you had an idea of, like, okay, that's all those terms in between. Okay, now I'm going to ask you, all right, how many times does 4x to the fourth go into negative 8? Okay, well, it should go in negative 2 times, because negative 2 times 4 is negative 8. But how many times does x to the fourth go into x to the third? It's a bigger variable, or a bigger exponent into a littler exponent. Well, you have to think about it. We are actually decreasing an exponent, so when we multiply, we need to multiply by a negative number because we're going to add the exponents. So what number plus 4 gets me 3? That would be a negative 1. So this would become 2x to the negative first. Okay? All right. Now if I multiply it and work it out, I should get negative 8x to the third. Okay, just like I predicted. And then when I minus it, okay, I'm definitely going to get 0, and that's what I want. Now here's a weird thing, is that when I rewrite it, it's just going to be rewritten as 3x to the fourth. That's not too abnormal. That's pretty typical. But then it's going to be minus 2 divided by x, because we're going to reciprocate that x to the negative 1 and just work with it that way. Okay. All right, the cool thing is, there's your answer. That's how it's going to work, and turn a long division problem into it. Okay. All right, now this one, once again, I'm going to treat it just like the other one. So this is going to be 3x squared minus 10x plus 3, and we're going to divide it. Now here's the tricky part, is I'm going to divide it by x plus 3, or x minus 3. Okay. Now here's the cool thing. All you have to do is pay attention to x and see how many times it goes into each one of these as we go. Okay? as long as you pay attention to that, that should take care of itself. It's really nice how it works. All right, so working with this, we're going to say, okay, how many times does x go into 3x squared? Okay, now here's the tricky part. Okay, it's going to go in 3 times, but it's going to be an x. So when I write my answer, I'm going to write it over here. On this other one, it didn't matter because we were dividing by a monomial, and some of you guys are probably going, wait, hold on, you wrote it over there, and I don't understand how you're doing this. Well, we're just going to re-represent it over here. When you do a binomial or a trinomial when you're dividing, which you'll get into Algebra 2 with that, but for right now in Algebra 1, you're going to rewrite it over here. Technically, it doesn't affect the answer at all. I'm sorry. Technically, it doesn't affect the answer when I get it, but it should help you stop at a certain point. Okay. All right. So taking a look at this one, so 3x times x is going to be 3x squared, which is what we wanted. Okay. But I'm also going to distribute. So first off, I distributed here. Now I'm going to distribute here and get that negative 9x right there. And that's beautiful because that's exactly what I wanted. Okay. Now when I subtract, you got to be very careful to understand that you are subtracting 3x, but you're subtracting a negative 9. Okay, so 3x squared minus 3x squared is going to get you 0. So that's a big fat 0 right there. Negative 10 minus negative 9 is negative 1x. Okay, and then when you do that, you bring down to plus 3. Okay, now that's going to be extremely helpful because now, how many times does x go into negative x? That would be a minus 1. Okay, so we distribute the negative 1, so we get minus x plus 3. Okay, and when I add these two together, I should get a big fat 0, which I do. Well, technically I'm actually subtracting them, but you understand what I'm actually doing. Okay, and the cool thing is that this is actually a good way to actually do some kind of factoring. Okay, now would you have to know this in the beginning to know? Yes, you would, but usually the problems will give it to you. Okay, so basically what that is 3x squared minus 10x plus 3. Now, I wouldn't divide it, but I could say you could rewrite it as x minus 3 times 3x minus 1. Okay? And that is actually it factored. And this is how factoring actually works and was discovered to work because they did long division. So this is actually old school, breaking down a polynomial into its factors and just working with it that way, okay? All right, you'll learn more about this in Algebra 2, but for right now in the beginning in Algebra 1, you at least learned how to do this type of stuff. Or I'm sorry, at least to do the basics, and long divisions is one of the basics. Now this problem is exactly 100% correct on how to do it and write it out. So if you need to watch this video over and over again to follow this method, please do so. Remember, I'm just paying attention to the x and seeing what it does in each term. Okay, I don't care about the 3. The 3 is consequential as I get to the end. Now, some of you guys might be asking, what if I got a different number other than 0 as the remainder? You would just write the remainder as plus or minus whatever the remainder is divided by this. Okay, and that's how you'd write the remainder. But for right now, if you can divide in with getting a 0 at the very end of your long division, you can rewrite that first polynomial as its factored form, and it's really kind of cool how it works. Okay, now some of you guys are probably going also, if we've got factoring and the AC method, why do we need to do long division? You'll learn later in Algebra 2 that when you're working for polynomials that have a degree higher than 3, that you're going to need this stuff to work with it. Okay, all right, but that's it for dividing polynomials. I'll talk to you later. Bye.